For some families, the cold was dangerous. Step outside on a winter morning, and within hours, the skin erupts in welts and the body burns with fever. Not an allergy, not an infection, a single gene, a built-in alarm wired to go off at the wrong moment. The gene is NLRP3. It sits near the far end of chromosome 1. It builds a protein that works as a sensor, a tripwire inside your immune cells, always listening for signs of danger. Its older name says it best: cryopyrin. In 2001, immunologist Hal Hoffman and his team in San Diego chased those cold fever families all the way down to their DNA. The cause was mutations in this one gene. They named the protein cryopyrin. Cryo for cold, pyrin for its fever-linked core. The mutation didn't break the alarm. It made it too easy to trip. But what was this alarm? A year later, in Lausanne, Jürg Chopp's lab gave the machine its name, the inflammasome, a cluster of proteins that, once triggered, switches on inflammation itself. Here is how it fires. A danger signal appears. NLRP3 snaps together and pulls in a partner protein, ASC, and an enzyme called caspase-1. Caspase-1 does two things. It slices a dormant messenger, interleukin-1 beta, into its active form, the body's master switch for fever and swelling. And it punches pores in the cell until it bursts, spilling that alarm into the surrounding tissue. Against a real threat, that is exactly what you want. The problem is what else sets it off. In 2006, Chopp's lab found the cause of gout, uric acid crystals that trip the very same alarm. Cholesterol crystals do it too, inside the walls of arteries. That is atherosclerosis. And clumps of amyloid do it in the brain, feeding the inflammation of Alzheimer's. One sensor, misreading the debris of common disease as an enemy. So switch it off. First, we went downstream. Antibodies that mop up interleukin-1 beta. One of them, canakinumab, silenced the rare fever syndromes. And in 2017, a massive trial showed the very same drug cut heart attacks. But the real prize is the alarm itself. In 2015, a molecule called MCC950 became the first to shut NLRP3 down directly in the lab. It stalled, but it started a race. Roche, Novartis, a dozen startups. And yet, after all of it, not one drug that blocks NLRP3 directly has crossed the finish line. The gene in 2001, the machine in 2002, the chase still on. One alarm wired into our joints, our arteries, and our minds, and we are only now learning to turn it down. The Gene Channel.